So in this section, we will discuss about higher order derivatives. So generally, higher order derivative means we are going to perform differentiation repeatedly. Performing the differentiation, let's say we have two notation. One of the notation is we have a function given by f of x. So the first derivative will be referred to as f prime x. So this is the first derivative. Then the second derivative will be represented with 2 dash or 2 primes. So this will be the second derivative. Then the third derivative, we will have 3 primes. So this becomes a third derivative. And for the fourth derivative, we use the Roman numeral 4 within parentheses, and this becomes our fourth derivative. So we can go on, and our nth derivative will be given by f n derivative of x. So this is the nth derivative. Now there is another notation. The first derivative is given by ddx of fx. The second derivative will be defined as d squared dx squared of fx. This is actually the same as saying we have the differentiation with respect to x of the first derivative dfx with respect to x. So the third derivative will be d3 over dx cube of fx, which simply means we take the derivative of df over dx. The fourth derivative will then be d4 dx4 of fx, and similarly the nth order derivative will be dn over dxn fx. Let's try to apply this. The rules will remain the same, or we'll understand this with the help of few examples. So here we have the polynomial function, and we need to obtain its first 4 derivatives. So let's begin by finding out the first derivative with respect to x. So we have x raised to the power of 5. When we apply the power rule, it will become 5 times x raised to the power of 4, plus applying the first derivative to 4 times x raised to the power of 4. So we have a 4 times 4, so that's 16x cubed, plus derivative of 2x cubed will be 2 times 3 is 6, so we have 6x squared, minus derivative of x squared will be 2x, plus derivative of x over 2, so that will be simply half, and derivative of 3, which is a constant, this will be 0. So this is the first derivative. The second derivative will be given by, so we take our first derivative and then again differentiate it with respect to x. So this will give us a derivative of 5x raised to the power of 4, so this will be 20x raised to the power of 3, plus 16x cubed. The derivative will be 16 times 3 is 48, so we have 48x squared, plus derivative of 6x squared, so this will be 12x, minus derivative of 2x, so this will be 2, and derivative of half, which is a constant, so this will be 0. So this is our second derivative. Let's find out the third derivative as well. So we will consider the second derivative and differentiate each terms with respect to x to obtain the third derivative. So 20 times 3 is 60, so we have 60x squared, plus 48 times 2 will be 96x, plus derivative of 12x will be 12, and derivative of negative 2 is 0. So this is our third derivative. And finally, the fourth derivative will be taking the derivative of the third derivative with respect to x. So 60x squared, its derivative with respect to x will be 120x, plus 96, which is the derivative of 96x, plus 12, so this is going to be 0. So this is how we can find out higher derivatives. That's a very simple. So this is not example 4, this is example number 1. Let's move on to the next problem. So we have our cosine function. Let's take the first 4 derivative. So we have f of x is equals to cosine of x. Then the first derivative of x f of x, that will be derivative of cosine function, which is negative sine x. Then the second derivative will be derivative of negative sine x, so this will be negative of sine of x will give us cosine of x. Then the third derivative will be, we have negative cosine x, and we know the derivative of cosine function is the negative sine function, so this will become positive sine x. And the fourth derivative will be derivative of the sine function, so we have cosine of x. Now if we see the first function, which is f of x is equals to cosine of x, actually we can give our notation 0, which will mean that we have not taken the differentiation yet. So here we can clearly see a pattern. So we can see that after 3 differentiations, we have obtained the same value cosine of x which we started with at the beginning. Now if we are to ask the question, what will be, let's say, the 98th derivative of our function cosine of x? So what will be this value? To do this, what we'll do, we divide 98 with 4, so that will be 4 times 2 is 8. So we have 98 is 4 times 24, which is actually 96 plus 2. So multiplying with a factor 4, that means we are actually at f of x is equals to cosine of x, and plus 2, the remainder plus 2 says that we have to go plus 2 units. So that means this is negative cosine of x, so the 98th derivative of f of x, which is cosine of x, is negative cosine of x. We can try out one more. So what about the 27th derivative of f of x equals to cosine of x? So 127 can be also written as 4 times, so 4 times 31, which is 124 plus 3. So we have a remainder of 3. So that means we are at the first step, which is f0x is cosine x. So 1, 2, 3. So our third value is positive sine x. So this is going to be the 127th derivative of f of x. Also, we can see that whenever we are taking the first derivative, third derivative, so that means the odd derivative, we are getting a sine x value, and whenever we take even derivative, that's when we get a cosine value. So the 98th derivative of f is a even derivative of our function x, so we should get a cosine function. So this is fine. And similarly 127, this is an odd derivative of our function, so we have a sine function. Let's go to the next problem. So we have a function g of x given by x times the exponential function. We need to find a formula for the nth derivative. So let's start with g of x. The original function is x times e raised to the power of x. When we take the first derivative with respect to x, all we have to do is use the product rule. So we'll take x times derivative of the second function e raised to the power of x as the function itself, plus the second function times derivative of the first function is x, which is 1. So if we take e raised to the power of x as the common factor, so we have x plus 1. Let's take the second derivative. So we have to take the second derivative of x times e raised to the power of x, which is actually this particular value we have just found out. So it's e raised to the power of x times x plus 1 plus the second term. This is simply e raised to the power of x. So we'll get e raised to the power of x times x plus 2. Let's take the third derivative. So we have to take the derivative of e raised to the power of x times x plus 1. So when we take the derivative, so this is what we should get, e raised to the power of x times x plus 2, plus we have again e raised to the power of x, which is the function itself. So if we take e raised to the power of x common, so we get x plus 3. So clearly we can see a trend here. So let's say we do further differentiation, then the nth derivative of our function g of x will be, so we see that e raised to the power of x is common in all the differentiation, and x is also common, plus 1 plus 2 plus 3, this is what we're getting. So that means this will be replaced with the value n, meaning when we took the first derivative we had the value 1, when we took the second derivative we had 2, third derivative gave us 3, so that means the nth derivative will give us n. So we have the function h of x equals to 1 over x. So we need to find a formula for the nth derivative. So we have h of x is equals to 1 over x. The first derivative will give us, so here we have to use the power rule, so this will give us negative 1 over x squared. Then the second derivative will give us 2 over x cubed. The third derivative will give us negative 6 over x raised to the power of 4. So here we can immediately see a trend is being followed. So let's say when we take the 0th derivative, so this is negative 1 raised to the power of 0, which is simply 1, divided by x raised to the power of 0 plus 1. We're just rewriting everything. Then we have the first derivative, so this is negative 1. We're simply writing negative 1 as negative 1 raised to the power of 1, means the same thing. And x squared will be 1 plus 1 equals to, so we have negative 1 raised to the power of 2, since we have a positive value, times 2 divided by x raised to the power of 2 plus 1. For the third case, the third derivative, we have negative 1 raised to the power of 3. So we have a 6 here. So this was simply 2 times 3 divided by x raised to the power of 4. So 4 can be written as 3 plus 1. So if we follow this particular trend, then the nth derivative of our function h of x will be, so we have negative 1 raised to the power of n. This is actually the n factorial divided by x raised to the power of n plus 1. So this is going to be the nth derivative of h of 1 over x. So let's say we want to find out the 77th derivative of our function h of x. So this will be simply negative 1 raised to the power of 77 times, we have 77 factorial divided by x raised to the power of 77 plus 1. So negative 1 raised to the power of 77, so that's simply negative. So we have 77 factorial divided by x raised to the power of 78. So this is going to be our 77th derivative. Let's go to the final problem. So we have the exponential function e raised to the power of 2x. We need to find its nth derivative. So let us begin. So 0th derivative, so that's given as e raised to the power of 2x. The first derivative will be e raised to the power of 2x, because derivative of our exponential function is the function itself, but we also have 2x instead of x, so we need to use the chain rule, and that will give us the value 2. Then the second derivative is going to give us 2 times 2 e raised to the power of 2x. The third derivative will give us 2 times 2 times 2 times e raised to the power of 2x. So we can see our trend is being followed. So the nth derivative of our function is going to be 2 raised to the power of, so when we had first derivative, it was simply 1. Second derivative means we have 2 squared. Third derivative 2 cubed, so nth derivative will give us 2 raised to the power of n times e raised to the power of 2n, because this is 2x, this is common to all the derivative. So this is the nth derivative of a given function.